Hello guys, welcome to another tutorial series. What we'll be talking about today is a continuation of our PIR motion sensors. In this case, we'll be talking about intruder detection system. Basically, what this system is meant to do is once it detects motion, to trigger an alarm such a way that whatever system that was put in place will alert the user that okay, there's an intrusion or there is someone or animal, anything around that vicinity. This can also be brought further by putting an SMS alert, maybe a Gmail notification using a buy link. This can also be improved in many ways, which we'll be looking into in this series because we'll be doing a lot of tutorial DIY using this motion sensor. So we'll look into a lot of them as we move along. So basically, what we'll be focusing on today is just this intruder detection system using this PIR motion sensor. So basically, in this tutorial, we'll be needing some things, which is basically our requirements. So the requirement for this tutorial will be Arduino Uno. We need Arduino Uno. We need our 16:2 LCD display. This I2C display, as you can see here. This module helps to limit the number of wires we are going to be connecting to this 16:2 LCD display. So we need a PIR motion sensor. So this is the sensor itself, which is doing all the magic in this tutorial series. So we need LEDs. The green is to designate our standby mode, and when intrusion is detected, it will trigger red, and a buzzer will also go off as that is going on. So we need a buzzer as well as part of our requirement. So aside that, we need jumping wires. So these connecting wires are just there to make sure everything we have on the requirement is connected together. So you already know the use of jumper wires and all that. So we're not going to dwell on this. So basically, we're going to move straight to the connection. Now, this is the basic connection we're going to be doing. As you can see, these are all the requirements we need for this project. Now, this is connection 1. We're going to be connecting the LCD ground to our Arduino ground. Next, we'll be connecting our VCC. As you can see here, we have ground, VCC, SDA, SCL. So we'll connect our VCC to our plus 5 volts. We need the 5 volt to drive this LCD. If you use 3.3 volts, it's not going to be bright at all. It might even malfunction. So we need 5 volts. This LCD is a 5 volts LCD display. So the next one is to connect the SDA to our pin 4, analog pin 4, which is A4 on our Arduino. So SCL, which is our serial clock, the SDA is our serial data, SCL is our serial clock. So we'll connect it to pin 5, which is our A5 on our Arduino. So right now, basically the LCD display has been fully connected to our Arduino, and what we need to do next is try and connect our motion sensor here. This motion sensor has 3 terminals. One is ground, one is VCC, and one is out. Basically, the moment you supply ground and VCC, this is the ground, this first pin here, and this is the VCC. This middle one is the out. Once you supply ground and VCC to this device, it starts working immediately without any configuration to start sensing motion. Once motion is detected, it will start sending a signal through this pin out. This out is the pin out of this middle pin here is the pin out, where the signal that is being detected is sent to a microcontroller to process. So right now we're going to connect this PIR sensor, motion sensor, start with the ground. So as you can see here, I connected the ground to this ground here. This notch here shows that there's a connection between this ground and this ground. So we are sharing a common ground in this case. So aside that, we're going to be connecting the VCC. The same thing we did with the ground, we did this with the VCC. We are taking the same common ground and common VCC. Instead of dragging this wire all the way to this side or using our V in, we just, since we already have a positive and a negative line here, we just terminated here. So like I said, this notch shows a connection. If you already know the electronics and you are doing this project in the first place, you should already know what this means. But for the sake of those who are new to electronics and just want to follow along, this is what this notch here, this circular dot means, connection point. So all we need to do next is this: connect the pin out. The pin out is connected to pin 11, digital pin 11, D11 on the Arduino. So what we need to do next, since this has been completed, we need to connect our LEDs. Currently, our LEDs, the ground has been both looped together. If you're confused about which one is the ground and which one is the VCC on LED, look through the glass terminal here. You will see a big notch. That big notch is the negative. Or you look for the longest leg. The longest leg on every LED production is the VCC as the power line. So if you can detect it through this notch, you use the longest leg. Sometimes an LED might be given to you and both legs has already been cut equal, or most probably it was produced like that. In order for you to avoid burning that LED, you just have to make sure you connect it correctly. So in order for you to know which one is VCC and which one is ground, you use this to identify. And if you cannot, maybe the LED is very blurred that you can't even see through this glass. Another way for you to do it is just to make sure you test using polarity difference. But make sure there's always a resistor attached to it when you're doing that test. If you're connecting positive to negative, the LED will not glow. So when you connect it rightly, the LED will glow. So the moment you are able to get the LED to glow, the terminal where you're connecting the red to label it as positive, and the terminal you're connecting the black to label it as negative. So that is for that. So let's connect the green LEDs. So right now, the negative has been connected to negative. This is the common ground, as you can see. Now what we need to do is connect the positive via our resistor to our pin 6. This has been connected, as you can see, to pin 6. Then for the red, connect it to pin 4. Pin 4. In the video tutorial, you see that I used two LEDs. The first green LED is connected to pin 6, second LED is connected to pin 5. Then the first red LED is connected to pin 4. The second red LED is connected to pin 3. So that is the way I used it, in case you're getting confused over the video and the schematics I'm giving to you. Normally, there's really no need for the use of two LEDs, but I just used it. In case one is misfiring, the system will still work. So, but in this case, you don't really need to. So that's why I just used one in this case. So what we need to do now is connect our buzzer, which is the last connection on this circuit diagram. So what we do here, as you can see, we've already done the connection of these three items: LCD display, PIR motion sensor, LEDs has been not connected. So let's connect the ground of this buzzer. Ground has been connected to common ground here. So you can see all the grounds are sharing a common ground. Now the VCC of this, because this buzzer is an active buzzer, it has positive and negative. So the positive of this will be connected to pin 2. This is where the signal will be sent through once a trigger is applied to this system. If you detect the motion, send it to the microcontroller will trigger this LED, and at the same time trigger an alarm via this buzzer. So this is basically how it is done. As you can see, the entire communication is complete, connection is all done. So this is pure circuit diagram. This is not a schematic, this is a circuit diagram of this whole device. I chose not to be using schematics anymore because I keep getting the comment that they don't understand the schematic diagram of most of these things. So why not just use the physical component? As you can see here, if you can't get this to work on your, if you can't get this connection to be done on your own, there's no way you will ever get it, because there's no need for you to even continue with this passion in the first place. So this is the physical Arduino, this is the physical LCD display, this is physical motion sensor, this is physical buzzer, physical LEDs. You can't get more than this. If I'm to use schematics here, the schematics of this and that of diode is almost the same thing. The only difference is that LED has two arrows going out of the diode. This is a diode. A diode is also a diode. The only difference between this and the diode is this is a light emitting diode and the other one is a regular diode. So the only reason why you have the two arrows going out of an LED like this is to show that it's a light emitting diode. So those are most of the complications people get when you use schematics. So that's why we are using physical component like this. Though it's more difficult to even do the connection when you are using physical component like this, because you have to start tracing lines and all that. But it's also easier. It makes the job less cumbersome. Most of the comment you'll be replying to, there's no need for it. You won't get those comments. The best you will get is appreciation and all that. So which is also okay for me. In as much as the comment is good, but at least it's better you follow along and understand what is going on than getting to start replying comments, because not all the time we have the time to reply comments. Thank you. I will also as soon as this has been completed right now, I'll show you a video representation of this on the breadboard and how it works. Thank you for watching. If you like this video, please do well to share, subscribe, and click the notification icon so that whenever a video is uploaded like this, you will have the courtesy of getting it firsthand on your notification bar. Thanks, and see you in the next phase.
Hello guys, welcome to another tutorial series. We are still on the motion detection series. Currently we are just trying to modify our motion sensor device. So you can see here, this is an LCD display 16:2. The system right now is saying no motion detected. Save. Once motion is detected, it's going to blink red and the buzzer is going to come up. The reason it's popping is because it's detecting little motion from my body, my hand gesture. That's why it's kind of popping up right now. So as you can see, my hands are kind of moving, so it's detecting that. Though the sensitivity is a bit low because I have to reduce the sensitivity in order for it not to be triggering every single movement on my body because of this recording. So basically what we're having here is a motion detection system that is able to tell on our LCD display when motion is detected on our device here. So basically this is a buzzer, an active buzzer. This is an LED which tells the state of the system. Once there's no motion, is purely green. The moment motion is detected, it becomes red here, as you can see. Like I said before, the reason is kind of popping up is because of the fact that the system is still detecting little motion from my hands, as you can see. So right now I'm just going to hold it. As you can see, the motion has been detected. You can see on the screen, this is it showing. As you can see, my hands are on it now. As you can see that now this system has been regulated such a way that the moment the motion is detected, it switched from standby mode to automatic alarm system. As you can see, here you go. Now the motion has been detected. As you can see, the red LEDs are blinking right now, as you can see, and the bullseye is very active. So this is just a continuation of the motion detection series, which we already started. We're going to be doing a lot of projects with this motion detection. So in our next video, in our next tutorial rather, I'm going to be making this same project using an OLED display. So I'm going to use OLED display in order to make it. So as you can see, it's still triggering. Now I'll remove my hand. It's still trying to detect a little motion from my body. Once the sensitivity of this system is increased, any little motion from my body, the system is going to detect, even as far as to 2 meters, 3 meters away. So this thing has been regulated to almost zero in terms of sensitivity. That's why it's only when it comes very close, like as you can see right now, that's when it fully detects, though it's still able to pick little motion from the environment as I'm trying to move my hands. So this is basically another way you can use this motion sensor. In this case, this is for burglar alarm or security alarm. In a situation whereby you don't want someone in an enclosed area, and you want a situation whereby if someone goes there or anything, maybe animal or anything goes there, you should be able to know. The system will tell you by triggering an alarm. We're also going to move this motion sensor project to a different level in such a way that this will be able to send you an SMS with time. We're going to be doing that across this series. Once it detects motion, it's going to send you an SMS that motion has been detected. So if you have CCTV camera in that area, you can also just check who is there, if it is a human being or an animal, because this motion sensor is able to detect objects with some level of heat signatures. Even if a goat goes near it, it's still going to detect it. So it's not all the time that it's going to trigger that is having a serious security breach. So that is why if you have a backup camera in a situation whereby you are using this kind of system in your environment, it's good for you to check so that you don't panic unnecessarily. So this is just how the system works. Like I said, in the next video, I'm going to be using an OLED display. The reason for this is because in a situation whereby you don't have a 16:2 LCD like this one, and you have an OLED. So guys, like I said before, we're going to be using OLED display in the place of this 16:2 LCD display. In a situation whereby you don't have a 16:2 and you have OLED lying around and you feel like carrying out this project, the aim of that is for you to be able to do the same thing we just did with this. And also, I'm also going to be switching microcontrollers across the line. I'm going to be using an Arduino Nano, and I'm going to be using ESP32 and ESP8266 that has no MCU. So whichever one you have will work. So these are different OLED displays. You can see this is a bigger one. These are brand new. So I'm going to be using them along the line. Now, if you look at these two OLEDs, this is a 1.3 OLED display. This is an I2C, and this is an SPI. This one is a simplified version of this. This one you just need 4 wires in order for you to use it using the I2C protocol. While this one, it requires about 7 wires in order for you to be able to use it. Both will give you the same thing. The only difference is that the connection and the code that will be written for both is what differs. This one here is an I2C. Let me pull this off. This is 0.9. So this is also a 0.9, but a square. This is a rectangular one. So we're going to be using this in our next project. So In the next one, there will be a tweak. So the system will be trying to detect a kind of a form of a radar using this very one here. So once it detects, it's going to tell you motion detected, just like this other one. Thank you for watching, and see you in the next video.